Hey guys, welcome back. Today we are going to learn how to find the area between curves. So, what am I even talking about? Let's say we wanted the area right here, all of this, okay? Now bear with me, it's going to take me a little while to explain why we do what we do, but it'll make sense when I'm done. So to find that area, first of all, let's give these things names. Let's say the top curve is called f of x. We'll call the bottom curve g of x. Okay, bear with me. All right, so I want to find all of that area. Well, first, visualize a straight line going from f of x to g of x. And I want you to think of that as like a, well, I can't get that straight to save my life. Okay, so think of that as a straight line, okay? And actually, instead of a line, think of it as an infinitely thin rectangle. Okay, for starters, instead of getting the area of all that red region, I just want the area of that rectangle. Okay, well that rectangle, what's the length of this rectangle from here to here? Well, that length is actually whatever the distance is from f of x to g of x. Okay, so it's f of x minus g of x, top curve minus bottom curve. Okay, that's the length of this rectangle. And it's top minus bottom. To help you understand, let's say you had just straight lines. 1, 2, 3, x equals 3, and x equals negative 1. If this is x equals 3 and this is x equals negative 1, what is that length in between them? 4. Why? It's 3 minus negative 1. So you got to subtract top to bottom. All right, so getting back to where we were, back to that infinitely thin rectangle. The length of that rectangle is f of x minus g of x. The width of it, if it's infinitely thin, we call that change in x, or dx. So this is my length, and my width is dx. Ah, finally some meaning to that dx. Okay, well that would be the area of this one rectangle, but I don't want just that. I want this rectangle too, and this one, 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 and all of those rectangles. Okay, well this rectangle still has a length of f of x minus g of x and a width of dx. Okay, it would just be different actual numbers depending on their value of x. So I need something to add up all these rectangles. I want this one, this one, this one. I want all these rectangles going across. Well, what symbol do we use to add them all up? The integral adds up all those rectangles. But which rectangles do I want? I want the one that starts here and ends here. So if we find that point of intersection, we'll call it A, and this one we'll call B. Then we integrate from A to B. All right, so let me try to summarize all of that again. Here we go. To find the area between two curves, you will subtract top curve minus bottom curve. Okay, and then you will integrate from point A to point B, their intersection. And that is the area in between here. Okay, again, the length of this rectangle is f of x minus g of x. That's the length. The width is infinitely thin change in x, dx. So our formula, and I don't really want you to think of it as a formula, it is subtract top minus bottom. Okay, make sure it's top, then bottom. Subtract those and integrate. So what you're going to have to do is make sure you know which curve is on the top. So you'll have to look at the graph or have another way of figuring it out. Like this would be a negative parabola, so I would know that one was on top. Okay, so you're gonna have to look at the graph, make sure you subtract top minus bottom, and you're gonna have to find where they intersect. Algebraically, you set the two curves equal, but since you're allowed to use your calculator, you can also just use the intersect function on your calculator. All right, so here's one example. Graph one of these in y1 and one in y2, and look at that graph. Okay, and it looks like this. And I want the area in between them, which is this itty bitty tiny little thing in here, and I can't even. So I'm going to zoom in. So hit zoom 2, and a little blinker comes on, and then hit enter. And if you zoom in, you get a little bit better picture. Looks like this. So what we're trying to find is this area right here. Okay? So we're going to do top curve minus bottom curve. The top curve, which one is the top curve? It's this guy. Okay, and that's the sine. So we're going to have sine minus the parabola x squared. Okay, then we're going to integrate from this point to this point. Well, this first point looks like 0. I think it is a 0. I can verify that it's actually 0 by plugging in a 0 here and here. Well, 0 squared is 0, and sine of 0 is also 0. So that's definitely a 0 right there, okay? Now I have to find the other point of intersection. So this upper bound right here, this is what I'm looking for right now, okay? So that's going to be this point of intersection right here. Now that I cannot guess and check what that is. So what you're going to want to do is use the calculator to find that point of intersection. So hit second calc and choose the intersect option. Okay, so you hit second and calc. Now how do you get the intersection? It's going to ask you for the first curve and the second curve. Make sure you move your cursor closer to this point of intersection than this one so that it knows which point of intersection you're trying to get. Okay, so you move over closer and then you click on one curve and then it'll ask for the second curve. You click on that, you just arrow to it and then hit enter again. Okay, make sure you get this number as the point of intersection right here. Okay, now let's finish this problem. That is our upper bound. That is the number that goes right here, 0.877. And then you're going to put this in your calculator, math 9, and that's it. Okay, but some technicalities. If you actually use this in your calculator, this rounded value, it can change your final answer dramatically. So you can write that on your paper so that you can keep in your mind what you're doing, but you actually want to type in all of these numbers or learn how to store them. So make sure you write all of these down on your paper. And then it's okay to write this rounded number, but don't use this rounded number. Make sure you use this number in your calculator. So do that for me right now, math 9. And let's see if we get the same answer. Did you get 0.136? Okay, remember, don't use these rounded values. Wait to round at the very, very end or you'll get it wrong quite often. Not always, but often, okay? So you write down this number if you want to, but you actually use this number and you put it in math 9. So that's pretty much it, okay? Remember, it's top curve minus bottom curve integrated from point A to point B, okay? Okay, so now what do you do if the curves flip-flop? Let me give you an example. Let's say you have one curve that goes like this. We'll call that f of x. It doesn't matter where it sits on the x-axis or on the coordinate plane. And the other curve maybe goes like, well, maybe it's a straight line and it just goes like this. We'll call that g of x. If it says what's the area between the curves, okay, well, the top curve switches. So if this happens, you have two areas, then you also have two shaded regions. Two shaded regions means you have two integrals, okay? So how are we going to do that? Well, we'll have to find this point of intersection using the calculator. I'll call it A. You'll have to find this point of intersection using the calculator, and I'll call that one B. And you'll have to find this point of intersection, and I'll call that C. When you integrate, you're going to integrate this region from A to B, and you're going to subtract top to bottom. Well, the top curve is the black one. That's f of x minus g of x. Then you're going to add this next area, this one. So there we're going to integrate from B to C, top minus bottom. So it reversed. That's g of x minus f of x. Okay? And then you can still put all of this in your calculator in one step. All right? Now, if these equations are ugly, then you already graphed it. You maybe put this in y1 and you put maybe this one into y2. If you hit the VARS button on your calculator, which is 3 buttons above the 9, you can type in y1 and y2 and not have to retype the entire equation. That's just an option if you don't find it to be confusing. You hit VARS, y-VARS, y1 and y2. So if you'd rather do it that way, it saves a little bit if these are ugly equations to type. Okay? If you don't use y1 and y2, then be careful. If this equation has more than one term, make sure you distribute the negative or use parentheses, both of these, okay? So moral of this story, if the curves flip-flop, then you have to flip-flop to which curve goes on top, okay? Top minus bottom, top minus bottom. All right, so summarize all of it. It's always top curve minus bottom curve integrated from point A to point B. And if they switch positions, you have to reverse what's on top. All right, good luck, guys. Hope it goes well. Here's your assignment. Okay, just make sure you graph each one. Find those points of intersection. Let your calculator do the work for you. Tomorrow we'll be doing the same topic without your calculator. Ooh. All right, good luck, guys. Bye.